We are going to represent a doubly linked list. Logically, we have discussed in previous video introduction of doubly linked list. Fine. So now we are going to create a doubly linked list having 3 nodes only, and after that we are going to display the data like 7, 1 and 3. This is how we are going to display the data. So first of all, you go through the video of introduction to doubly linked list. I will provide you the link of that video in the side button. You can check out there. Now see how we can represent a node of a doubly linked list, that we have already discussed in the previous video. So I am going to write here that thing. So this is how we are going to represent a node of a doubly linked list. Data type is a struct node. 3 parts of this node are there. Data, one is next pointer, one is previous pointer. This pointer is going to store address of next node, and this previous pointer is going to store address of previous node, right? So now one head pointer is also there. We are going to maintain this pointer. We have this pointer when we are dealing with the program. So this pointer is what? Containing address of the first node. You can say it is a pointer to the first node. So this is how we are going to declare a pointer. This is name of the pointer. This is a pointer, that is why we are writing here asterisk, and this is a pointer to node. Which address it is going to store? Address of this node. Fine. So here you will write address of that variable whose address this pointer is going to store. So now the type of this node is what? Struct node. We have defined our own data type, that is struct node. See here directly you cannot write 7. This will give an error. Why so? Because when you are writing this thing, it means you have just declared, you have just defined your own data type. The memory is not been allotted yet. Fine. So you cannot directly write here, you cannot store any value here. First of all, we will declare a variable, either a variable of this struct node type or a pointer. Using that variable or that pointer, we can access the members of structure. So I hope you know the concept of structures, how we can use the structure in C language. Fine. Now globally we declare this thing, because if you globally declare this data type and this pointer, then in any function you can use this head pointer and this data type. Fine. Because in this case we are going to declare two functions, one is create and one is display. So globally out of the main function and out of all those functions I am going to declare this. Now I am going to define a function that is create. So now I am going to write down the code to create this linked list. See, it is very much similar to the singly linked list code. In that case we have seen how to create a singly linked list. So first of all, we have to create a node to store this data, to insert the data in the linked list. Initially we assume that this list is empty, right? So if list is empty, then in head pointer you are going to store what? 0. Fine. So you can initialize this head pointer with 0. I am going to write down that thing also. So now first of all, we are going to create this node dynamically. Dynamically we are going to assign the memory to this node. And how you can dynamically allocate the memory? Using malloc function. The malloc function syntax we have already discussed many times when we were discussing linked list concept. So how you will write down that thing? See, the syntax says you will write that malloc keyword, and here the size you want, for this node the size you want, how much size? 4 for this, 4 for this and 4 for this. So here what we will write? Here we will write size of, in bracket you will write the data type. The data type is what? Struct node. So now automatically how many bytes would be allocated? 12 bytes would be allocated. And what malloc function will return? It will return a pointer to the first byte of that allocated block. Now suppose this block has been allocated in the memory. How many bytes? 12 bytes, and the 12 bytes are there in this one. 3 parts are there of this node, this and this, and the address of first byte is 250. So the address of this block is 250. So that is why malloc is going to return this address. So you can say it's going to return what? A pointer to the first byte, or you can say that void pointer. And now you have to store this address into some another pointer. Obviously we are going to store this address into a pointer, na? We use a pointer variable. So we are going to declare one another pointer variable. Suppose here I am declaring asterisk new node. This is newly created node. For this I am taking new node. See, if you don't declare globally, then here within this create function you can also declare what you can write, struct node asterisk new node. So if you are using this pointer only within this function, so better you declare this new node pointer locally, not globally. So now this will return a void pointer, and this new node is what? It is a pointer to node because type is struct node. So you have to typecast this thing. How to typecast this? You will write what? Struct node asterisk, right? And whatever this malloc will return, where we are going to store that thing in new node. So here you will write what? New node. So this is how the dynamically the memory has been allocated to this new node. So here you can say this new node is a pointer that has been created, and this pointer is going to store what? Whatever malloc will return, that is 250. It is going to store 250. So it will point here now, right? Now this has been created. Now we ask from the user which data he wants to insert. Suppose I have inserted 7. Using printf and scanf we are going to take input from the user. So how you will write? In scanf what you will write? %d, and we cannot directly access this data. How you can access this members of structure? Either using that variable of this type or a pointer. So we have declared here pointer. So now how you can access the part of this newly created node? Using this pointer. So here what you will write? Address of, first of all, the pointer name, then this arrow symbol, and which part you want to access? Data part. So data I want to access. See how you will draw this arrow symbol? Simply that hyphen and angular bracket. And if you don't write this thing, another method is what? You can also write something like this. Asterisk, name of the pointer, and then dot, and which field you want to access. Here I want to access data. So you can write down this thing here. So suppose here I have entered 7. So here and here, first of all, we will store what? Null. So how you will store null here? Simply you will write what? New node. You want to access this part, so name of this pointer is what? We have taken previous. Previous is equal to 0 and new node. Next is also 0. So now this is done. Now we want to insert this newly created node in the linked list. At starting, head is equal to null. So here you can write within this function, you can also write head is equal to 0. See, this is the case. Head is equal to null. So how you can insert this thing here? Simply you have to update this. Fine. In head pointer, what you will store? The address of this node. Address is 250. So here you will store 250. So now head is pointing here, right? And in the next node also 0. There is no next node. There is no previous node. That is also 0. So simply what you will write here? In head we are going to store head is equal to, from where you can get 250. See, this pointer is also containing 250 because this is pointer to this node. So in head you can write new node, right? If head is equal to 0, in that case, now we have one node in the linked list. Now I want to insert another node, the second node. In that case, head is not null. Now head is containing 250. So in that case, how you will insert? So in else part, what you will write? So now see, in the linked list, I have only one node. I have only one node inserted. Now I want to insert another node. So suppose I have created another node by running this code again. Again the memory has been allocated dynamically, and suppose the address is 200. This 200 would be passed here, the new node. So here this new node pointer is containing the value 200. It means it is now pointing to this node. And the data we have entered, that is 1, and the previous pointer is containing null, and next pointer is also containing null. Now see, if head is equal to null, but head is not null. Now control will go into else part. Now how we are going to insert this node here? Now which link you have to update? See, here in doubly linked list you have to update 2 links. Fine. See now, if you want to insert this after this one, so this node is going to contain address of this node because this would be the next node. So that is this 200. 200 would be here. So here rather than 0 we will store 200. Fine. By doing this you can establish this link. But this is not done. Now this also you have to update this thing also, because every node is going to contain address of its previous node also. So now here in this part, which you are going to update this thing, and what should be there, that is 100 address of the previous node. Now we have established this link also. So now if I ask how you can access this part, so simply you will say, ma'am, pointer to this node is this head. So simply what we can write, head of next, this pointer is next, head of next is equal to, from where you will get this 200, from this new node, because new node is containing address 200 is equal to new node. So one link has been updated. Now I will ask how to update this link, how you will access this part of this node. Then you will say, ma'am, we have a pointer to this node, that is new node. So we can access this using new node. So new node, and the name of this part is previous. Name of previous is equal to, from where you will get this 100 address of previous node, and in head we have 100. So here we can store head, and this is done now. Now you will say that this is done, ma'am. Fine. Okay, fine, we have inserted this thing. Now the problem comes when I want to insert a third node. Now see, now I have created another node by running this code again. This node we have inserted this 2 here, the data here, and both the previous and next pointer is containing null. Now if head is equal to null, but head is 100, so head is not null. Now we are going to do this else part. Now we are going to run this code. Now see what happens. Here first line is head of next is equal to new node. Head is containing 100. Using this we can access this node. Head next means this one. So here we will store new node. So what is the value in new node? See, we have created this node. So this address would be contained in this new node pointer. So here this new node is now containing 300. It means it is pointing to here. So now according to this logic, the new node, this 300 would be stored in head next. Head of next, that is here. So here 300. It means what? This pointer is now pointing to this node 300. It means this link has been broken. But that should not be a case. In next line also new node previous. New node previous is here and is equal to head. Head means 100. So it is pointing to here. So now this is also pointing to here. So that is not correct. So this logic is not correct. Now what you will do, here we will take another pointer to node. You can say temp. This logic we have already discussed in the singly linked list also. So now within this function we can declare another pointer, that is temp, you can say. Now how we are using this temp? See now. Now temp is another pointer. And now what you will do, we cannot move this head, we will move this temp. First of all point to this, then this, then this, then this, like this. Fine. So now what you will do, when you will insert the first node, if head null, then you will insert this node. In that case, head is also pointing here, and you will set what? Temp will also point here. You will write something like this. So here what you can write, head is equal to temp is equal to new node. So both head and this temp is pointing to this, now this first pointer in the node. So now what you will write in else part. So now I am taking a case that we have inserted one node and I am going to insert second node. After that we will insert the third node, right? So I have created this node. I have inserted the data 1. Here we have 0, 0, and new node is a pointer that is pointing to this node and containing the address of this node. Fine. So now what you will write in else part. How you will update this thing and this thing. How you can access this part, either using head or using temp. So here I am accessing this using temp. So I can write temp of next is equal to address of this. From where I can get this? From new node is equal to new node. So now this is containing 200, means we have established one link. So now you have to establish this thing also. How you can access this thing? Using new node previous is equal to, you will store here what? The address of previous one, right? So now I will write here address of previous one is in temp. So I will write here temp. We are not going to write here head, because we have discussed if you write here head, what problem would be there. So I will write here temp. So this has been set, that is 100. So it is going to point now here. One more thing, what we will do now, we are going to move this temp, right? So now temp is equal to, temp is pointing to this node, now temp would be pointing to this node, that is we are going to store 200. So from where you can get 200? From this new node. So temp is equal to new node, and this is the closing of else part. So now temp is containing 200 and temp is now pointing to this node. Now both new node and temp is pointing to this node. We have successfully inserted the second node. Now see, if you want to insert the third node, we have created this node, right? We have inserted the data. Here we have null and null. Head is equal to 0, head is not equal to 0. So we are going to enter into else part. Now see, in else part what we have written, temp next. Here what you have to do, you have to update this thing and this thing, right? This is going to contain address of next node and this pointer is going to contain address of previous node. We are going to update two links. So now how we can access this thing? See here in this case, now new node is pointing to this node because we have created new node. So here in this new node pointer, this 300 would be stored. Now this new node is not pointing here. After creating third node, it is pointing to here. Now see how we can access this part, using a pointer obviously, and we have a pointer temp pointing to this node, so we don't have any problem. That is why we are taking another pointer temp. Temp next, temp is 200, temp next is 0. This, what you will store here? New node is containing 300, so here you will store 300. It means it is going to point here. 300 is address of next node. One link has been established. Now second, this, how you can access this part? Using new node previous. New node previous is equal to, what value will store here? Address of previous node, that is 200. From where we can get 200? Temp is containing 200, so is equal to temp. Now here 200, so it means it is going to point here. And again one more thing, temp is equal to new node. Now temp is equal to new node, that is 300. So now temp is pointing to here, right? That is why I am taking this temp. Again if you insert fourth node, no problem. In that case new node would be pointing there when you will create the fourth node, and we have the address of this previous node, so we can easily update the links, right? So that is why I am taking this temp. Now if you want to run, I want to write a program something like this. After inserting first node, it will ask, do you want to continue? If you will press 1, then you can insert the second node. If you again press 1, then you can insert third node. So you can insert as many nodes as you want. So now for that thing you can write, after this else part you can write same this thing we have discussed in singly linked list. See, you can write the choice of the user, and here you can write type 0 or 1. If the user press 0, it means he don't want to continue. If user press 1, it means he wants to continue, right? So now for taking the input from the user, you are going to declare another variable, that is choice. So we can declare this choice variable within this function somewhere here. Suppose I am taking here int choice, right? And in starting I am taking choice is equal to 1. So when the user enter 1, the choice is 1, it means new node should be created again and again. So that is why you are going to write this code into a loop. Fine. So here before this line new node is equal to struct node, here you will write what? While choice. It means when choice is equal to 0, when you will pass 0 here, this code will not be executed. So that is why here you can start while loop and here you can close this while loop. And if you press 0, it means the new node would not be created. If you press 1, it means here 1 would be passed. So this code would be run again. So this is how you can create as many nodes as you want in a linked list. Now suppose after inserting 7, 1 and 3, again it will ask, do you want to continue, and you have pressed 0. It means this code would not run again. So after this you can call what? Display function, and this list should be printed, that is 7, 1 and 2. So how the display function will work? That function is same as singly linked list function. The coding would be exactly same that we have discussed in singly linked list. Fine. So I am just going to write down that code here just for a brush up. You can write down this code, you can pause the video and you can note this code. So I am going to rub this now. So now this is the code for the display function for displaying the content of this list. This code is exactly same as the code of singly linked list. We have discussed this code in that case in detail, so I am not going to discuss it in detail here, right? This is the same. We have discussed we have taken one temp, another pointer. We are going to start here. First of all, temp is going to point from here. Temp is equal to head. So here, and one by one we are going to print the data and then we will move temp. See, we are going to print the data, then we will move temp is equal to temp next. Then print the data, again we will move until temp not equal to 0. It means when temp becomes 0, then you are going to stop, right? And in main function you can call the create function also and this display function also. And see, this thing we have declared globally outside of main function and outside of both the create and display function. So in next video I will discuss how to insert a node in singly linked list at beginning also, at any position also and at end also, and after that how to delete data, how to delete node from a doubly linked list. So I will see you in the next video. Till then, bye bye, take care.